two. I think we're missing. Well, it's recorded, those. Okay. Questions, comments? Okay, everything cool. Before I go into today's, I want to just finish up something I wanted to do yesterday, but ran out of time. And that is if you recall, I was giving an example of using an enum to represent different types of dice, and then testing it basically using this class to kind of redo a previous assignment I had you do, just kind of straightforward. And the one say what's the advantage of doing it this way? Well, not a huge one, other than the fact that you can model the six different types of dice, whereas in the other one it was only just the six-sided die, excuse me. And then what we did was just to kind of verify that for each of the different number of sides of dice, that it was at least roughly having the right probabilities for each. So in kind of running it. Oh, thank you. There we go. Okay, so so here we just verified that each of the six ones were actually being created, and here we kind of picked one, the 20-sided one, rolled it a bunch of times, and then wanted to compare what the estimated probability of getting each one was with the theoretical one. So in this case, if I have 20 sides and they're all equally likely, then the theoretical probability would be 1 over that. Okay, fairly straightforward. And then, we look, and because it's a simulation, we get values, are they close enough? Well, they look close enough. Can we definitively say they are? Not without some extra tools in our kit. In other words, are these values enough to say, yes, they're being correctly generated? Again, sort of looking at, this isn't a statistics class, but if we have statistical tools in our belt, we can apply say a goodness of fit test to see whether or not these probabilities are actually correct, and come up with when you're kind of making assertions and things like that from a simulation model, you definitely want to use some sort of valid statistical approach, because when there are, quote, random things, and the air quotes are the fact that it's pseudo-random, you're doing a random experiment, and so that's why we make you take what are sometimes called classes in statistics. So, okay, the other thing I wanted to add was, and this is something that in your probability course, I don't know if they kind of mentioned that, but do you remember they talked about the concept of a Bernoulli trial? Does that, okay, so, and, they did things like, if I conduct a certain set of Bernoulli trials, if I conduct n Bernoulli trials, then how many, what's the distribution of the number of successes? You remember what that one was? Binomial. Okay, so on the other hand, if I conduct trials until I get a particular, until I get a success, do you remember what that distribution was? A geometric. Yeah. Okay. Yeah, Poisson is a very important distribution, but in this case it's geometric. And it turns out that if I want to find, in this case, what is the average number of rolls that I have to make until I get a particular value? We could have made this fancier and had like a sort of a craps game where you say, okay, if I have a given point, then how many rolls? Anyway, but actually that's a little more complicated because that's kind of more like a, don't want to go down too many rabbit holes. Anyway, so how can I want to estimate the average number of rolls it takes to get a 1 for every one of these dice. So how do I do that? Well, I'm going to say that this is how many trials I'm going to run. And notice that as much as possible, what I like to do is create a variable, and then the advantage of that is that in this particular case, this is how many trials I'm going to run. I have a variable here, so instead of kind of looking for it in the for loop, I look for it in the variable. So if I want to change the number of trials, I just change it here. You know, 6 of one, half dozen of the other. Just in general, using variables is, in my opinion, a good idea. Okay, so I'm going to do, like, if I conduct one trial, I'm going to come up with some number. So let's say it takes me 10 rolls. Okay, that'll be 1. The next one might take 15. The next one might take 3. Okay, so what I'm going to, how do you compute an average? And, you know, you add them up and divide by the number, right? Okay, so I'm going to create a sum, which is going to be the running total of the number. And because I know how many I've done, then at the end, the sum divided by the number of trials is going to be my estimate of the average. Okay, so for the number of trials, I want to create a for loop. But then within each one, I want to roll until I get a particular value. And so the appropriate control structure there is some form of while loop, not a for loop, because for a for loop, I need to know how many there are. That's why it works for here. I know I'm going to do this many trials, so I use a for loop. Here, I don't know how many rolls it's going to take, so I'm going to use, so some form of a while loop is the appropriate one. Now then, given that, I have a choice between a while and a do while. Okay, I've chosen do while here. You could make it work for either one, but in this case, a do while is, in my opinion, the appropriate one. Do you see why?
You have to have at least 1 roll.
Yeah, you need at least 1 roll. Because I say, how many rolls? I can't get 0 rolls, so I need to do at least 1, and so a do while is the appropriate one. You can always, for any given thing, you can use either a while or a do while. But the thing is that in order to use a while, you'd have to kind of do some contortions. The most natural thing, if I want to do at least 1, then it's a do while. If 0 times is going to work, then it's the while. So choosing the right control structure is kind of okay. So what I want to do is I want to keep track of the last roll, because that's going to tell me whether I get a 1 or not. And for each of the trials, I want to count the number of rolls, so far. I'll call it number of rolls so far. So, okay, so I roll the die, and that's my last roll. And then I have 1 more number of rolls so far than I had before. Now, just stylistically, I know in seeing some of you like the plus when you're doing something like that. It's not the worst thing in the world. For me personally, I've because these increment operators are they have there's kind of a gotcha with them when you use them in an expression. So for me, I prefer to only use them in for loops. Now, if it's the only element on the statement, then it's not the worst thing in the world. So I'm not going to ding you if you like that. I prefer to do it this way. Um, because this, it just, well, you can make a case for either one. Anyway, so, okay, did a roll, got one more roll, and then here's the test. While the last roll is not equal to 1, I'm going to keep doing that. And then I'm going to bounce out of that when I finally got a 1. So when I get a 1, this becomes false, and so I bounce out to here. Now again, so look at the scope here. So the scope of number of rolls so far, again, is within the for loop. And likewise, the last roll, I could have, actually, it would be slightly better if I moved this declaration inside here to narrow the scope. Yeah, good. In fact, let me do that just to. Oh, I'm sorry. Yeah, no. This is a. Take that back. I can't do that because I need to test it outside of the scope here. Okay, so this is one of the conflicting criteria when you're using while loops. So if you're testing for a variable within the while loop, and well, in particular for a do while loop, the scope of the variable you're testing on has to be outside of the loop. So that's why it has to be there. Okay, and then once I bounce out, I'm going to increment this with the number of rolls so far. And it turns out for the geometric distribution, when you're doing at least 1, the theoretical average is going to be 1 over the probability of a success. So here the probability of success is 1 over the number of sides if it's a good die, and so the average would be 1 over that, which would be simply the number of sides. So when we run that, I get an estimate of 19 point blah blah blah. Theoretical one was 20. Again, is this close enough? I would need to do a statistical test to see that. But again, but here looks good. Okay. But the reason I wanted to do this is because this is a useful exercise in choosing the right control structure. Okay. For a for loop, if you know how many there are, then the for loop is the appropriate one. If you don't know how many there are, then one of the while loop forms is the appropriate one. And if it's okay to never do it, then a while loop is the appropriate one. If you need to do it at least once, then use a do while. So that's that. Okay, now on to today's. All right, now this. I like a lot of what the book is doing. The book is sort of leans very heavily on this UML thing, a little more heavily than I would. If it were up to me, there would be a little bit less of this. The main utility of UML is the idea that you can, as much information about your program you can do without writing a single line of code, the better. In other words, if you're building something and you don't have a plan, then it's probably not going to go too well. So these UML diagrams are like the blueprint or the plan. And the thing is that kind of sitting down and writing code, there are all kinds of issues that you need to deal with that. But when you're trying to design a program, then you need to do much more thinking, as it were, much more creativity. And the thing is that if you design at least the structure well, then the coding becomes infinitely easier. Whereas if you sit down, our tendency is to sort of sit down and just start writing code because I want to get something. And so what the advantage of these UML concepts are that instead of sitting down and sort of trying to bang out code, I do some thought beforehand. In other words, I'm measuring a dozen times before I cut once. Okay, so now and then they, as part of that, these are sort of things that kind of came up when people started using this object-oriented stuff, is that combining objects, and how do they relate to each other, and that's where it's sort of basically the association is really the key relationship. In other words, you have objects that are associated with each other. Just as an example, that we've seen is in the case of the die class, there is an association between the random class and the die type enum. So in other words, what is the nature of this association? Actually, in this case, the association could be, this would be composition. So the die has an instance of random and it has a die type. So the has a relationship is really the important one. Now the difference between composition and aggregation can be a little bit fuzzy, but for me it's like we'll get to that one. Okay, so but in other words, when you have objects within objects, then that's what this association thing is about. So, and then now here's I know I'm asking you to be able to explain the difference in composition and aggregation, but it's kind of it's a bit fuzzy. So I'm not going to hammer on that too much, but just understand that there is sometimes a subtle distinction between them. That's less important than the fact that when we're designing classes, and we'll see an example. I want to work through an example of this at the code level as well. That they have these relationships, and then just some things that I've kind of touched on. Sometimes an instance variables have a getter but no setter method, and this is something where I kind of I'm a little bit at odds with the author of the book, because in my opinion the author has setter methods where I don't think they should be, and so because that's something that I have my undies in a bunch. That's something that you need to also. So just understand the principle of that. And then in the process of this, we're going to look at a situation where one very common aggregation is where you have not just one object, as we had with the die and the random and the die type, but you have a bunch of them, like an array. And so we're going to look at a situation where you have an array of objects, but you don't know exactly how many there are. And then it turns out when you're testing that, as we've seen with arrays, it would be nice to just sort of print an array and say, okay, this is the contents of the array. Unfortunately, we can't do that. However, Java does provide a number of really useful convenience methods in what are you doing to me here? They want you. Okay, convenience methods in a class called arrays, and then on next week we're going to kind of circle back to some of these static ways of referring to things. Okay, so the important concept here is that one of components, and we've seen sort of two flavors of classes. We've seen main classes, like a main class is one that has a main method, and that's where we're kind of running things. And in those main methods, what we're doing is what we're doing is just testing things. And so the tests are kind of throwaway. In other words, they're not things that we're going to necessarily keep around and reuse. But a component class is something that we can we want to be able to reuse it in a number of different contexts. So an example of that, the die class is a good example of that component. Why? Because there are many different, you can envision many different situations in which might want to be rolling dice. We could be modeling a craps game. We could be modeling Monopoly. We could be modeling, actually the book has this sort of snakes and ladders example where you're rolling dice. So in other words, when you have a class and you can create an instance of it and just automatically get a whole bunch of capabilities, behaviors, then it's a component. In other words, it's something that we want to keep around and reuse. Another example is the random class. You know, we've used the random class in a number of different contexts. That's a component. So the one distinction about composition would be if there's kind of a lifetime dependency. That's sort of one criterion. In other words, in the die class, for example, we have the random and we have the die type, and those were, once those were set, that for the life of that object, it had that particular die type, that particular and that particular instance of random. So you kind of being a quote part of, whereas aggregation is kind of more of a looser relationship where you might have they might change throughout the life of the object. Again, the distinction can be kind of a little fuzzy, but just that, you know, type of thing. So we can think of like, for example, like, we have components that can only be accessed through the class interface. So for example, your graphics card, we can think of that as part of the computer, and we never, when you're displaying graphics, you don't interact with the graphics, at least in this class. Now, maybe in your graphics class, you'll be doing stuff like that. But even there, you're not directly accessing the graphics class. Even if you're writing graphics programs that directly use the graphics card, you're not touching the graphics card. The software is. You're writing code that drives the graphics card. In something like Java, we can write things which ultimately use the graphics card, but there's actually one more layer removed from that. We can't go in and directly instruct the graphics card to do something. For that, we need a low-level language, a lower-level language, or like a library. But Java cannot do that because of the Java virtual machine creates a sandbox that only allows you to interact with the hardware components through a straw, basically. You know, so I mean, obviously, if we're interacting with the file system, we're displaying things here. Obviously, that requires graphics type of stuff, but we cannot directly access the hardware in a Java program. That's why, I mean, if you're doing something like writing a device driver, you don't write them in Java. You write them in C usually. That would be it. Okay, so and die type was a part of the die class, so that would be considered a component. But others might be have components that are more dynamic. And you know, an example of this might be an external hard drive, or in this case, maybe I mean, I can think of this projector system as an aggregation of my computer. Why? Because I can run the computer with or without this, and so when I plug it in, all of a sudden I'm using it, and then when I unplug it, I'm not. So that's more of a dynamic relationship, and that tends to be aggregation. So so another example, and again here you could sort of make a sort of talk about this, but here, so let's say, and again thinking of kind of like a drawing program or something, and so for a drawing program, I would have an abstract view that would consist of a number of shapes. So if I'm kind of drawing a bunch of things, then one way to represent it would each of those things, like circles, rectangles, whatever, each of those would be some kind of shape. And that shape would, one way, you know, in addition to, I would obviously need a bunch of data for that, but the key data would be a set of points that would identify where the edge, the intersections of the lines. Let's say if I'm doing it using lines, I might even use Bezier curves or something like that. But the key things there are a set of points. And so if I have say a circle might be represented by the center together with some other data. And if it were a rectangle, it might be represented by the two of the upper and the lower endpoints. So I have an array of points that would represent a shape, and for that given shape, though, then those points would be how that shape was being represented. Yeah.
So just like a succinct way to sum up that slide would be to say that shape is a composition of points, and then the picture is an aggregation of shapes.
Yeah, yeah. That's why? Because when if in the drawing program, I create some shapes. I might delete them. So with respect to the view, the shapes are dynamic in that they come and go. Whereas for a given shape, it would have a particular set of points. Now, you say, well, if I would move them, then the way to kind of move them, I still would have the same points, but the value of the points might be changing. In other words, if I take a circle and I move it somewhere, then the center point would move, but it would be the same object. That's how we do it. I wouldn't remove the point and then put another point in it. I mean, but maybe I would. Now the distinct. I mean, it's like in a way, it's kind of splitting hairs. The key thing, though, is the fact that these objects are kind of related to each other. So these points are inside. Here, the declaration of the point is out here. These points are kind of inside this shape, and likewise, this view consists of these shapes. So these programs now, they're like these sort of nested Russian dolls in a way. So that all this is going. Now here's the thing, is that do you have to do it this way? Absolutely not. If you're not in an object-oriented design, were there graphics programs and things like that before object-oriented? Absolutely. So, but think about what you would have to do. If you just had one thing, it would have to take care of all of these activities. Now, and if you were writing something like this, I like to start with the finest thing. So I would sort of write and test and verify a point. And then I would create shapes. I would, and then test those and make sure those are all working. And once those are working, now when it comes to the view, then what are the activities that I need to do that? How do I add a shape? How do I move a shape? How do I just, maybe in this case I would also, because of something called model view controller as a bigger way of looking at things, I would have the view would be an abstract way of representing what is being displayed, and there would be a separate thing that would be displaying what the contents of the view are. That's sort of another whole other thing. But okay, so the kind of association is just the relationship between the objects. So aggregation and composition, those are specific types of association. Starting next week, we're going to be looking at inheritance or subclassing, and that's another way that classes relate to each other. In other words, these classes are totally independent of one another. But we're going to, you can have classes that are subclasses of other classes. So why would you do that? Well, we'll see next week. Okay, so just to try to make this a little more concrete, I wanted to, the book has a nice example that expands this course idea, and here's the design. So if you remember, we had a course, and the course had a bunch of stuff. And they say, well, okay, now what we want to do is we want to take the next step. And just in the sense of meta, when you're developing a complex program, my experience and the experience of many others is to be kind of doing it in stages. And the stages are, like in this particular case, the first stage was, we created a course and it did certain things. So that first stage, the first milestone of the first stage was, okay, create a course, it had a name, it had like the number, it had, well, whatever, I forget these, I'd have to look at the code again just to see that. But it had those certain things. And so we could say we reached that milestone because we had a course and it passed these tests. And now the next stage is, okay, well now we want to have our course include a number of different modules. And as part of that, the modules are going to also have information such as how many credit hours it's going to have and how is the module going to be assessed. Now, for whatever, now my hypothesis is, and one of the reasons why I chose the book is because actually the approach that this author takes is actually much more appropriate for this class than most of the other texts that I've tried to use. Why? Because those other texts are typically for a beginning programmer who's this is Java as a second language, and so there's just a lot of stuff that teaching you about things that you already know. The examples are just very, in my opinion, just really mundane, very simple. On the other hand, when it comes to style, and again, this is just sort of my, I don't know, maybe some therapy will help on this, but I have certain really kind of weird ideas about how things should be. And so here, my hypothesis, the author, I think, is kind of, Java is not his first language. It's not my first language either, but I'm kind of much more of a kind of a Java junkie, as it were. Anyway, so I like to use enums much more than, like the author was using strings for these. And the thing is that if you're using, and this is just something to kind of watch out for. There's nothing wrong with kind of using strings as a placeholder for some of these things, but if you're in a situation, as we remember with the die thing, there were exactly 6 types of dies that were used in that context, because there were 6 types that could be created with with equal faces. So I used an enum instead of a string. Why? Because if I have a string, it's just too easy to put in garbage. With an enum, the only thing that can go wrong is if I give it a null. So that, in other words, the compiler is going to keep things separate. So here, okay, so I have an assessment. So this is the module now is going to have a name. It's going to have how many credit hours, and it's going to have an assessment. And our assessment is going to be an enum. I should have said called it an enum, and so the 4. In a bigger example, there would probably be more, but practicum, coursework, exam, or none. That's what it is. All right. So the idea is let us do that, and in the process, okay. And what I'm going to do is I want to put this in a different package. So let's what was that? Okay, I'll call it course in a new package there. And so what I want is I want to create the module. So let's start with the module. Okay, so and then just reading right off the UML, and you can probably I have the okay, names can be strings. Why? Because there are lots of different possibilities. And here's the author is from New Zealand, and so they were calling them points, but just here we call them credit hours. That's just kind of what it is. All right. So we do this in steps. So now notice that there's a instance variable called assessment that requires another thing called assessment, but I don't want to deal with that just yet. I want to actually first work with the fact that a course is going to consist of a number of different modules. Why? Because there are some issues there, and okay, so let's, okay, so when I instantiate one, and this is one of these examples where okay, the name of the name of a module and the number of credit hours, to me, these ought to be immutable. In other words, if I create a module, kind of just like and I call it something, I mean, but it might be I don't know, it says beginning UML or whatever. Okay, so I do that, and it has so many credit hours. That's kind of what it is, and it's not that these can't be changed, but like at least here at NPS, if I want to change the name of a course, I have to kind of submit a form to the academic council, and then it has to get approved, and blah, blah, blah. Likewise, if I change the number of credit hours, I have to go through a whole thing for that. So it's not, anyway, so the book will tend to give setters for these. And the reason why I don't is because if you have a public setter, you're communicating the fact that this instance variable can be changed by somebody, and you may not want to do that. Okay, so, but nevertheless, I might want to okay, let's select the getters. Fields with the accessors, make sure these are private here. And then I want to make it the last method. There are credit hours. And actually for this, what I won't do it here, but I want to make a note if it's less than 0. So I'll make a note to do that. But I want to, and then the other thing is it using toStrings. Whenever possible, like just for testing purposes, what's nice about this is that I don't have to use this, but like if I just want to say, okay, print out what the module is and I want the information about it, instead of having to kind of write all this stuff each time I want to do that, I just sort of print the module, and then there it is. And we'll see, we can kind of reuse that. All right, so now,
So,
yes.
why are the getters private?
That is a great question. They should not be private. Okay, so if that happens, yeah, good eyes. Let's select getters, because I accidentally set there. Oops, that didn't do it. So they are private because I was using the same, because NetBeans is sticky, so I was actually creating some private things in a different account. Why for that? Instead of doing it this way, I could have created a private setter. That's what I was kind of playing with. So, but good eyes, thank you for that. Okay, so now the thing is, I want to connect this to the course, because that. Now here's my course, and actually my course is in the other package. Now one of the cool things is that I can just kind of grab it. If I put something in the wrong in a package I don't want, I can just kind of drag it to the right one, and it will actually refactor my course in this case. So, and it changed the package declaration and everything. Okay, so now the course has some additional things, and so what are they? an array of modules and a count of the modules. Oops, and let's see how easy it is to forget. Okay, all right. So, and where did I just got that right from the UML. And, all right, now here's the thing, is that I don't want setters on these because how many modules are going to be in a course? Well, each course is going to have a different number of modules. So again, this is where the aggregation idea of stuff kind of comes in. I don't know how many there are going to be. I don't want to set that. I do need to instantiate this array, though. And now the book, okay, we're going to start with 20. And the book says, okay, you can have no more than 20. But what I want to show you is that, tell you what, let's even do it that way. Actually, no, yeah. Do I want to show you lazy yeah, yes I do. I want to show you lazy instantiation. Okay. Okay, I'm not going to do it this way. I'm going to do it here. Okay, so when now I could have added to the added an array of constructors to the an array of modules to the constructor, but instead I just want to show you this. Now here's the thing: when we add a module, when I first try to add this module, okay, here's what we want to do. Okay, so I have this array of modules. I want to say, here they are. When I start adding them, I want to keep, the first one is going to do that, and then I want to increment the module count. Okay, and this is sort of one of my stylistic bugaboos. You could actually, one thing a lot of people will do is they'll put that in there instead of doing the other. That's not a mortal sin or anything, but to me it just kind of is. I like to have as few things happening on one line of code as possible, ideally just one. So when you do this, there are actually two things going on. I'm incrementing the module count, I'm setting it to the other thing, and I'm exploiting a little hidden feature of these increment things where this is an expression. And what's the value of this expression? So if module count is 1, what's the value of this expression? Is it 1 or is it 2? It's 1, because when you have it as a postfix, the value of the expression is the old value. That is a gotcha. Because when you look at this, that's a gotcha. That's why I never use the increment operator in something else. Now, when I try to do this, do you know what's going to happen when I try to execute this? Correct. I'm going to get a null pointer exception because for precisely that reason. So what I'm going to show you, this is called lazy instantiation. And lazy instantiations, now I have two choices. Like one was what I was about to do, which was instantiate that array in the constructor. But the lazy instantiation says this: if the modules is null, then instantiated. And what I'm going to do, just to kind of show you, let's just sort of instantiate, give it at least one to start with. And then what's going to happen if I try to add another one? Then, okay, so now, and let's just to make it, this isn't totally necessary because the default value is 0, but in general you don't want to rely on default values. So if module's null, that means that I'm adding the very first one. And so if I'm doing that, then the count is 0. And now, okay, so modules 0 is going to be module, and now the module count is, okay, so that's actually, okay, actually the module count is really still just that. So what I want to do is say else where do I want to put that? Okay. Okay, so here's how we'll play this trick here. Okay, put it out there. Okay, so in other words, I'm going to initialize it at -1, and then when I add 1 to it, it's now going to be 0, and now it's always going to be the correct one. The next time I do it, modules has been instantiated, but now what's going to happen on the second one? So what's going to happen when I add the first one? It's going to instantiate my modules array and kind of initialize this here. Now my module count is 0. Actually, it should be 1. So this damn off by. See how insidious this this business is. All right, now it's going to work. Okay, so now there, I have one module and the off by 1 thing here. So if you remember, I was complaining about that before. This is pretty much why. If arrays were kind of normal, then we wouldn't have to fuss so much with this. All right, now, so the first one, that's going to work. Now, what's going to happen with the second one? I'm going to get an array index out of bounds exception. So what do I do? Well, else if module count is, okay, now if that's equal to the module's length, then, okay, what I'm going to do is what I need to do is use this wonderful method called arrays in Java. And what I'm going to do is I'm going to copy the old one, and and this is a common thing, I'm just going to double it. Okay, now what this does, this is this arrays thing I was referring to earlier. This is a set of static methods, and we'll talk about what static methods are next week, because we're going to circle back to talking about static stuff. What this does is this takes an array, and then this is the new. In fact, let's look at the Java doc for this. And copies a specific A, truncating or padding with nulls if necessary, so the copy has a specific length. Okay? So what this will do is that if it's now, if I've run out of room, it's going to double the length of my array, and then I'm always going to have more room. Now here's the, okay, just the last little bit, and I'll have to take this up again when we meet next week. But all right, so let's say that I want to, I don't want to set this, I want to get it. And let's kind of put it here. Okay. All right. Now the problem is that this is actually another mortal sin that the book actually does, because this violates encapsulation. If I'm going to do this, what I need to do is use this clone method. In other words, this returns a copy of the array instead of the array itself. You always want to do that. Now here's the problem with this, and I'm out of time, and I'll have to fix it when we meet again. But now, what am I going to get when I, so let's say that I've expanded my modules are now, let's say I have 8 of the 8. The array is of size 8, and I only have 4 modules in there. So what I'm gonna have if I return this? I'm gonna have 4 modules and then 4 nulls. Is that, do you want those nulls? No, you don't. Okay, so what I need to do is only return the modules that have been added. Okay, and this doesn't do that, but I'll put a pin in that, and then we'll come back to that. And then, oops, actually so for next week, we're going to circle back to section 6.8, and then 7.5 is a very cute little application of this composition thing. So